Welcome to Enots Engineering, I'm Alan. Today we're making a stop to fit the cross slide that prevents the tailstock hitting the glass scales. We'll also be looking at some anomalies that come up with the digital readout and how to set the digital readout to get the diameter you need. So let's go into the workshop and see how we do it. This is what we're making today, a simple stop to fit on the saddle, and that will be made out of this piece of aluminium. It's already got a thread, it's like a 5mm thread in the end. So what I want to do is machine this end with a 3/8 thread, this end to that length. Stage, you just measure the bar with a micrometer. .7713. So to set the x-axis, which is the diameter, we can ignore the y-axis because I've moved the saddle, but the x-axis I haven't moved the tool, it's still in the same position. So now we can feed in here 0.7713 and press enter. Now you can see the reading that's come up is not exactly what I fed into it, and I think the reason for that is it rounds it to the nearest micron because it's a metric scale. On the x-axis I have 0.375, which is the diameter I need, and on the y-axis I have 0.98. Well, I wanted that to be 25 millimeters. There we are, in metrics 25mm. So you can flick between the two and see. So there I've got the diameter in imperial and the length in metric. If I turn my tool out away, you can see the diameter gets bigger, and as I turn my tool in, the diameter gets smaller. So that's reading the right way. It's a 3/8 Whitworth die. This is just my die guide. It's a holder, just consists of a handle, diameter to hold your die with some grub screws, and a diameter that fits on the holder. You just move it into the job. And on the headstock, I'm just going to fit this in the back of the headstock. It's an expanding diameter there, and the way I expand that is inside here I have a cap head that goes through and pulls this cone in. That expands, grips on the headstock, then you can turn the chuck with this spanner on this hexagon. Feed in the die. There's the thread. I'll take that out. You have a look under the cross slide, you see there are two holes there. Both of these holes are threaded, and they are to hold your travelling steady. But as I've never used the travelling steady, all I'm going to do is use one of these holes for this stop, put a washer on the end, fix the stop into the hole. The stop is fitted onto the slide. I just measure the length, that's about 64mm. I wanted it at 55, so I've got a few mil to come off this end. We'll see now, as the tailstock comes in, it touches that and keeps the tailstock from hitting the guard. So we'll just take this out. Measure that, it's 61.5 roughly. So I need 6.5mm off this face. Return the part to the chuck. Touch the tool to the face. Zero the y-axis. Put it back onto metric. And go in 6.5mm. Change my tool for another tool just to put a chamfer on the corner. Use this parting off tool. We'll just measure the length. It comes up at 55.08. Screwed it in tight, and on the end I've stuck a piece of felt so that this gives some protection to the metal against metal. The felt comes in a sheet, sticky back, and you just peel them off. These are made for protecting wooden surfaces from scratches. You put these on the bottom of your items that you're putting on a wooden surface to prevent it scratching. So that will just stop the metal against metal. When I bring the tailstock in, it hits the stop, and the gap between the stop and the metal is about 1 mil, 2 mil. So if I take the guard off now, just to see if there's any swarf under it. You see, it's clean underneath. This just slides back under. It seems to be doing the job. See how we get on with that. Well, that's the tailstock stop. The stop is just here. As the tailstock comes in, hits the stop. Well, that's it for today. I hope that was useful, and hope to see you next time on Enots Engineering.